Greetings. Welcome to the interweb. I have a great example here for you of Hess's law. It's number 22 off of your homework packet on thermodynamics. And what we're going to try to do here is take the equation that's boldified up top and find out the enthalpy of this equation by manipulating the bottom three equations that we have here. And so we're going to manipulate them by either multiplying them by successive integers or by flipping them back and forth in order to get our target equation. All right? And so let's first off, I'm going to rewrite the target equation down bottom. And I'm going to say I have 2 N2s plus 5 O2s. And that ends up getting me 2 N2O5s. Now this is a target both with coefficients and with reactants and products. And the three things we have top we can play games with in order to eventually get that, right? And so let's take a look at what our reactants are to start off, let's say, right? And I say, well, I have some certain reactants. I have nitrogen here, and I have oxygen here, right? Now we have a particular equation here that contains, well, both nitrogen and oxygen. And so we're going to use that equation. But then I look at the amount of nitrogen and the amount of oxygen I have, and I say, look, down bottom, I have 2 nitrogens. And up here, there's only 1 nitrogen. So I'm going to rewrite that equation. And I'm going to take that particular equation, which is, first off, N2 plus 3 O2s and plus an H2, and it gives rise to 2 HNO3s. And we have something that's going to work for us. However, if we want to get 2 of them, what I'm going to do is I'm going to multiply the whole thing by 2. By doing that, that gives us 2 NH2s, 6 O2s, 2 H2s, and 4 HNO3s. By doing that as well, our heat that was originally up here is going to change. It's going to go from, well, 414, and we're going to multiply that times 2, and that's going to end up becoming negative 828. And so this is going to have the value of negative 828 kilojoules. Now, we've taken care of some of our reactants, right? We've taken care of the nitrogen, we've taken care of the oxygen. Now let's look at a product. And if we take a look at our products, we say, well, what type of products do we have going? I have N2O5, and where can I find some N2O5? Aha, here's some N2O5. But it happens to be a reactant in this particular situation rather than a product. So, well, I have an option here. What I can do is I can flip this particular equation. So instead of writing it as written, I'm going to flip it around and say, all right, then I have 2 HNO3s. And that gives rise to N2O5 as well as H2O. And I like that. That gives me a product. But now look at our products. Like I've mentioned, we have the appropriate product here and the appropriate product here. But kind of like before, where I had only 1 nitrogen and I wanted to then have 2, I only have 1 in my test equations, and in my final target equation, I have 2. So what I'm going to do is I'm going to multiply that also by 2. So I go ahead and say, look, here's me multiplying this entire thing by 2. That gives us a 4, a 2, and a 2. Now, what do we do to this particular enthalpy? Well, up with our delta H's, we have to flip the sign first off and make it a positive 86 kilojoules because I switched the direction when I flipped it. But then I also multiplied it by 2, so I'm going to multiply by 2. And that's going to give me the grand total of positive 172 kilojoules. So what I've done so far is I've taken into account my reactants, my products. But now this whole thing is going to add algebraically And I haven't canceled everything out. I'm on my way. Because look what I've done. My HNO3s, which I find here, right? Let me highlight those. My HNO3s here and here, those don't appear down bottom, so they have to cancel out. And look, I have one on the right-hand side of the arrow, which stands as an equal sign, and I have one on the left-hand side of the arrow, which also stands as an equal sign. And so what I can do is I can cancel those things. It's a beautiful thing, because there's 4 on this side and 4 on this side, right? And those cancel out, and it's excellent. I like it very much. Well, then I also look here and I say, look, I got hydrogens here. And the hydrogens that I'm interested in are found in this equation right here, right? Are there any hydrogens down bottom? The answer is no. So I need to get rid of those hydrogens. I also have 5 oxygens, and there's 6 up top. So I can't have 6 because the whole thing has to algebraically add to my target equation. And so what I want to do is I want to somehow manipulate the last equation to do that for me. Now look at the last equation. Hydrogens are on the left. Well, in my first equation, my hydrogens are also on the left, and they would add in this situation. And we actually don't want them to add. We want them to cancel. So I'm going to flip my last equation around and go something like this. I'm going to write 2 H2Os, which gives yield to an O2 plus 2 H2s. And by flipping that around, we have to make sure we're careful with our enthalpy, which is here, and make that a positive 571.6 kilojoules. So I flipped that one. Now let's take a look at what I want to end up with and what cancels. We have another cancel going on here, and it's very nice. Look, I have 2 waters here, and I've got 2 waters here. Is there any water in the target equation? No. So we're good. Then another issue that we had here were the hydrogens. I have 2 hydrogens here. I have 2 hydrogens here. They cancel. Then look, I have a single oxygen here, which cancels out one of these 6, which makes it become a 5. And now, watch how nice and neat this is. 2 nitrogens, 2 nitrogens, 5 oxygens, 5 oxygens, 2 dinitrogen pentoxides, 2 dinitrogen pentoxides, and everything else cancels beautifully. There's the goal. I think we've done good. Now the last step we want to do is we want to add up all of our enthalpies. Since we were careful with changing the signs when we flip them, and multiplying them by the integer that we used on our equations, now we just got to press buttons on our calculator. You press all the appropriate buttons and you get negative 85 kilojoules, which is our ultimate answer. Really hope you enjoyed Hess's Law. Have a great day.